Today, we're going to talk about one of the biggest headaches on the planet, plastic waste. But here's the twist. What if all that trash wasn't a problem, but actually a resource? A couple of recent breakthroughs are showing us how we can turn plastic waste into clean hydrogen fuel. So, how are scientists pulling this off? Let's get into it. First, you have to understand the scale of the problem. We're churning out over 30 million tons of PET plastic, water bottles, that kind of thing, every single year. And despite all the talk about recycling, get this, only 9% of it actually gets recycled. The rest, it's just piling up, creating a huge crisis. So that really sets the stage, right? We've got two massive problems staring us in the face. On one side, we're drowning in plastic. On the other, we're desperate for clean energy. But what if the answer to one problem was literally hiding inside the other? The key that unlocks this whole idea is a process with a pretty cool name, photoreforming. This is the science at the heart of both of the amazing solutions we're about to look at.
So, what is photoreforming? Well, in simple terms, it's a clever way to use light, like from the sun, to kickstart a chemical reaction. You add a special material called a catalyst, and it uses that light energy to split water and make clean hydrogen gas. At the exact same time, it uses the leftover energy to chew up plastic waste. Now, this diagram shows just how elegant the whole thing is. Think of it like this. Sunlight zaps the catalyst and gives it a bunch of energy. The catalyst uses half of that energy to pull hydrogen out of water. Boom! Clean fuel. And the other half? It uses that to attack the plastic, breaking it down into other useful stuff. It's a perfect two-for-one deal. Okay, so let's look at our first approach. I like to think of this as the designer solution. This didn't happen by accident. This was scientists meticulously engineering a brand new material from scratch to do this job perfectly. So what did they design? Researchers came up with this new material called a high-entropy oxide, or HEO for short. The best way to picture it is like a custom-made cocktail of 5 different metals all blended together: titanium, zirconium, niobium, hafnium, and tantalum. And let me tell you, making this stuff is a serious process. It's not just mixing things in a lab. They have to melt the metals together, then put the alloy under insane pressure and twist it, and then bake it in the air to get the final powder. It's some serious high-tech manufacturing. So the big question is, was all that work worth it? Oh yeah, this chart says it all. The new HEO catalyst produced 8 times more hydrogen from plastic than the current industry standard. 8 times. That's not just a small improvement, that is a huge leap forward. But wait, there's more. It's not just about the hydrogen fuel. The process also turns the old plastic into other chemicals that are really valuable. So you're not just making clean energy, you're also making products you can sell. And that economic angle, that's a really big deal. All right, now for our second method. And this one has a totally different story. It wasn't designed from the ground up. Nope, this one was a complete surprise, an almost accidental discovery that really paid off. I mean, listen to what the lead researcher, Professor Erwin Reisner, said. He basically admitted they thought using acid would be impossible. The conventional wisdom was that it would just be way too corrosive and would just dissolve the whole system. But they stumbled on a catalyst that could actually take the heat. And this is where it gets really clever. They realized they could use another huge waste problem, old battery acid, to pre-treat the plastic. So you're taking 2 different kinds of nasty waste and using them to solve each other. It's brilliant. The process itself is pretty straightforward. First, you use the battery acid to do the hard work of breaking down the tough plastic molecules. Then, their special acid-proof catalyst comes in and uses sunlight to turn those little broken-down bits into clean hydrogen and another useful chemical. And check out the durability here. This system ran for over 260 hours straight in the lab. That's almost 11 days without any drop in performance. It just kept on chugging along. That proves the chemistry is incredibly stable, which is exactly what you want to see. Okay, so we've got 2 incredibly cool breakthroughs. Both show we can turn plastic into clean fuel. But you're probably wondering, what's it going to take to get this out of the lab and into the real world? Well, let's be real. There are some big hurdles. You've got to figure out how to go from a tiny flask to a giant industrial reactor. You need to build reactors that won't get eaten away by acid. And maybe the biggest one, You have to make it work with the messy, mixed up, dirty plastic that we actually have in our recycling bins.
But here's the ultimate motivation. Here's the game changer. Because you can sell all those valuable chemical byproducts, some models showed that the total cost to make the hydrogen could actually be less than zero. Think about that. We could literally get paid to turn our plastic trash into clean fuel.
Professor Reisner puts it perfectly here. This isn't some magic wand that's going to make all the plastic in the ocean disappear tomorrow. But what it does do is prove that we can change how we think. It shows that waste doesn't have to be waste. It can be a resource. And that really leaves us with a final, pretty powerful thought. These breakthroughs force us to look at our piles of garbage and old batteries in a completely new light, not just as a problem to be managed, but as an opportunity. What if the key to a clean energy future is hiding right there, in our biggest messes?